Alright, 2. Boiler water treatment and control. The reference of the boiler water treatment of the late 19th century with the relay with the process of the remove of the scale of the boiler required with the much of the loss of the effort of the time of the boiler operator forgotten. Remove cooked potato from the boiler. Water with the determine the starch from the potatoes covered with the soft sludge rather than the hard scale of the beauty form and the sludge with the even remove the hard scale other than natural organic with include lithium with the tangent with the water with the plant medicine with the plant extra with the manure with the coffee ground with the juice similar result of the term of the addition phosphate by result of the juice with the manageable sludge although starch and lineages and tangents have been used to supplement phosphate. Phosphate is still very commonly combined with the water with the treatment of chemicals early used with the alkaline material will include lime soda ash, caustic soda, oxygen scavenging stuff with sodium sulfite with the found with the effect of the permanent preventing oxygen corrosion. Many of these materials are still used today with a wide range of the water treatment of chemical currently available allow for the development comprehensive approach with the industrial boiler water treatment including specialty with the chemicals such as clients, polymers, and aminamines. Alright, your boiler deposition formulations dissolve solids of the boiler feed water with the became of the main concentrate of the boiler water steam generated with some of the dissolved solids that came out of the solution with the precipitate with the scale with the boiler tube. Some of the dissolved solids can be sludge, mud in the boiler for the adherent deposit over the boiler tube. The deposit due to the heat transfer scale can occur with the included isolated spot due to the water evaporation where the steam bubbles forms of the heat surface of the film water with the saturated between the boiler with the tube wall becomes concentrated with the dissolved material with this thin layers as much as 30 degrees Fahrenheit hotter than the average boiler water. The temperature of the local condition cover the precipitation of the dissolved solid with the local formation of a scale. In Figure 2.1 shows the localized scale of formation with the heated surface at the high and lows and the dissolved concentration gradient, hot water, steam water, tube bubble. Sludge deposit with the sludge deposit can form with the precipitated material with the boiler water stick with the boiler tube with the hot surface. The result is the same with the phenomena described in 2.1. Scale and sludge often form together, dissolve in the solid materials. Some of the dissolved solid material may become less soluble with water temperature and improve the situation and occur with most of the solid that constitute with the calcium, magnesium, hardness. As a result of the property of these materials, the tend to scale with the hotter air of the boiler because of the remaining soluble with the cold air of the boiler. By using appropriate form of the water treatment of these scaling agents can be removed with the boiler and shifted the water either by entering the boiler with external treatment or after the internal treatment, although there is benefit to remove the dissolved magnesium, calcium, and minerals there for hardness before they enter the boiler. See paragraph 2.2 for the proper chemical with the treatment that can be effectively controlled with the treatment internally over the boiler. Common scale found with the boiler is the most common scale with the material with the calcium, magnesium salt with the iron oxide, calcium, magnesium salt with the deposit with the white and off-white with the iron oxide scale with the red and black with the deposit with the type of the scale. Can be identified accurately both with the deposit of the insula and L with the common if they have more than one type of the scale with the deposit of the calcium carbonate. Calcium carbonate scale with the white off the white color is also formed with the breakdown with the calcium bicarbonate with the heat with the calcium carbonate scale with is formed with both untreated boiler with the improperly with the treated boiler with the drop of the dilute with the acid solution on the deposit that will cover the bubbling of the calcium carbonate scale with as a result of the relief of the carbonate for the procedure for the be used to identify with the type of the scale. Calcium carbonate scale can result of the where there the calcium hardness in the boiler feed water due to the improper dissolve in their operation where there is an adequate level of sludge and scale condition dispersion. Calcium sulfate. Calcium sulfate or gypsum alphalate with a tan color is often formed with the boilers using hot water, high hardness, low alkalinity without proper treatment. The acid additional strong acid dissolve with the calcium sulfate scale with no gap of the bubble. The formation and relief of the carbon dioxide. The calcium sulfate is much less common than calcium carbonate with a much form of the calcium hardness in the boiler with the feed water due to the improper dissolve in their operation where there's an adequate level of sludge scale and dispersion. Calcium phosphate. The calcium phosphate form that dissolve with the calcium 3 bar with the reaction with the phosphate with the treatment. The chemicals added with the boiler water with the proper treatment. The control of the calcium phosphate forms a sludge that will remove the blowdown. The calcium phosphate with the committee deposit with the scale of the pH with the boiler water level in an 11.0. The sludge contaminant in addition is not used in addition with the strong acid that dissolve the scale with a fairly easy with no gas bubble formation. Magnesium phosphate. Magnesium phosphate scale with the off-white deposit with the form of the reaction. Magnesium salt with the feed water with the phosphate used with the boiler water treatment of the one only with the both the hydroxide content of the silica contact boiler water with the additional strong acid that dissolve with the scare fairly readily with no gas bubble formation. Magnesium silicate. Magnesium silicate scale with the off-white deposit with the form of the magnesium silicate feed water with the pH above 11.0. Form the silica level to meet more than half of the phosphate level of the boiler water normally with the forms of sludge with the will be removed with the blowdown, but form the scale with the deposit with the tube of the sludge contained with the not present for the most half of the building not remove the deposit with the caustic specific the chemical needed to remove the magnesium sulfide scale. Iron oxide, iron hydroxide. Iron oxide scale with the iron hydroxide scale with the red and black deposit formed with the iron salt with the dissolve with the feed water. The react with the hydroxide found with the boiler water. Usually dissolve with iron introduced with the system. Condensate with the return with the tube with the corrosion. The iron oxide can be the proper with the scale with the boiler tube with the proper tube with the sludge. Conditioner is not present with the proper water treatment. The deposit should form in the sludge rather than scale will be removed with the blowdown. The presence of the iron oxide on the internal boiler system can be used with the co-oxygen corrosion of the boiler metal. External boiler water treatment. The strategy for the external treatment is to remove the unwanted impure with the backup will make up the water before they can enter the boiler. With the proper external treatment, it can be eliminated. At least minimize the scale with the corrosion form condition, minimize the internal water treatment required to protect with the boiler system compounds. External water treatment, the high pressure boiler system. The high pressure for the boiler, the great need for the high purity of the feed water. The 5 kilogram per second of the water tube with the boiling operating at 900 pounds per square inch gave required with the deionized feed water with the external treatment operated as the RO by demineralization. External treatment of low pressure boilers. Low pressure boilers operated with a simple external treatment. There's sometimes no external treatment at all. At 3,450 pounds per hour with 100 horsepower with the fire tube operated for less than 15 pounds per square inch gauge that may require the use only of sodium xylate softener with the water treatment. The small heating boiler is returned to over 99% of the condensate may not require the external treatment, in particular with the makeup of the water, loss hardness, condensate but not contaminated. Internal treatment of the boiler water. Internal treatment of the boiler water for the process of the acting, the chemical of the boiler, the control of the deposition with the corrosion, internal water treatment together with the boiler, proper blowdown, control of the water impurities. They have not been removed to reduce the external treatment. The prevention of the scale of the formation. Internal boiler water treatment of the scale of the prevention form. Usually solubilizing with the chemical treatment program, with the precipitating with the chemical treatment problem, solubilizing treatment program, use the chemical design with the keep the scale with the cover of the material and with the hardness of the mineral ions in the solution, where the precipitating treatment program use the chemical design to react with the hardness cover of the material with the precipitate with it as a sludge that will not adhere with the tube with the surface, but both solubilizing and approach and the precipitating approach require good blowdown control but to keep the hardness sludge level of the chemical performance capability. Low pressure boilers. Low pressure steam boilers, boiler system that use the little to no makeup of the blowdown with usually no not chemically treated with the scale of the because so they do to allow for the makeup of the water to demand, but there is no continuous addition of the scaling agent present within the makeup of the waters of the boiler. With very high makeup of the requires over 1% of the per month. If the makeup of the water is over 300 parts per million, total hardening for the treatment of the program is required to partake of the boiler system. High pressure boilers. High pressure boilers must be either the precipitating type of the water treatment chemical program or the solubilizing type of the typical treatment program. Precipitating water treatment program. A precipitating program off the process of the react with the calcium phosphate sludge called the hydroexpedite. They act both the sludge conditions disbursement magnesium react with the hydroxide silicone with the magnesium silicate sludge deposit with the serpentine with the sufficient hydroxyl alkalinity. Causticity is required to allow the formulation of the proper type of the sludge with a sludge of that properly formed condition. Fluid is enough to remove through the bottom of the blowdown with the boiler. Some sodium hydroxide may be required to maintain the appropriate hydroxide alkalinity causticity. Phosphate precipitating agents prepared either the orthophosphate. Orthio means single phosphate, but it has one of the several forms of the polyphosphate. Poly for the multiple phosphate molecules bonded together. Sodium hexametaphosphate with sodium triopolyphosphate, sodium prophosphate, pyrophosphate are examples of polyphosphate. Boiler polyphosphate breaks down the orthophosphate due to the high temperature for the polyphosphate can add either to feed water directly to the steam drum. Orthophosphate can or should only be fed in the steam drum, not into the feed water, since they can react with the hardness of the mineral ions to form scale in the feed water lines. Alright, solubilizing water treatment program. Solubilizing program use the more with the following chemical to keep the scale with the form of the material of the solution with the phosphate that is known with the organic phosphate, the chelines of the polymers, solubilizing agents such as the phosphate, not to be confused with phosphate chelines, polymers of the common chemical used with the boiler water treatment, the formulation, chelines and chelithanol diamanium tetraacetate or EDTA and nitrotetracyclic acid. Bind chelate, calcium, magnesium, and iron using phosphate chelines require special injection system, excellent feed control with the extent of the free phosphate with the cheline, but they can attack with the metal surface the cause of the corrosion. Although the phosphate with the aggressive with the cheline or treatment long chain the water so will come compound with the actual chemical each actively side of the brain with the perform vary with the function such as stabilizing disbursement agglomeration, crystal distortion, preventing water deposit, preventing boiler deposit. The polymer do not attack the metal surface. They can be fed into the feed water line directly into the boiler steam drum through proper injection equipment. Alright, boiler specific treatment program. The high pressure boilers over 900 pounds per square inch and high quality feed water with this is produced with the extent of the external treatment, thus scaling form number 2 with the knob and normally pressed with the water with the cannot from the scale of the boiler. These boilers often use water treatment programs designed specifically for the particular boiler. These programs require the external control of the water chemistry involved with complying with the coordinated phosphate, congregate phosphate with equilibrium phosphate, all vital treatment with the boiler pressure for the level usually found with the operation with the drive of the turbines for the generation of electrical power. Alright, determination of the chemical treatment of the feed rate with the development of the chemical treatment of the program involved with the selecting type of the chemical used with the selecting the appropriate concentration level of each of the chemical when used with the combination of the other chemicals. So with the required chemical treatment with the addition with the screen with the ensure with the proper water with the treatment, the blow down with the discharge of the rate can be used with the calculate the rate with the chemical addition, the amount of the chemical required to replace with the loss of the blowdown meet when the treatment the objective is in practice with the chemical feed with the equipment itself to deliver the chemical a proportion feed on the demand with the base of the operation must keep the treatment level with the prescribed control range adjusting pumping and timers for the evidence cycle on the concentration within the system selection with the type of the quantity required with the chemical treatment is the issue involved with both technical concerns and ancillary issue the performance of the installation with the concern with the area with the procurement the contract of the budgets. Example below illustrate the phosphate the demand similar approach of the could be used with the technology in case of the sulfite with the treatment requirement that most very first satisfied with the with the oxygen feed water with additional sulfite with the defeat with the intane residual excessive amount of the boiler water to ensure the adequate protection. The second part of the example ensure that take into account with the treatment of chemical formulation not composed with 100% of the active ingredient with the formulation not but must often less than 50% active. That can be little as 10% active the chemical for the balance of formulation using being water. And this shows your example. The note, the calculation does not incorporate the phosphate reaction precipitation hardness precipitating the HMP with the required with a slightly greater. Preventing sludge deposit. In either lower pressure or high pressure boiler with feed water hardened with the dissolve of the mineral with the precipitate in the boiler prevent with the formation inherent with the sludge deposit with the natural and synthetic or both the water suitable to organic chemical with the add with the boiler water. The organic chemicals help to create with the sludge storm of the crystal structure of the skull and forming the compound with the preventing of the formulation of the scale of the properly formed with the condition sludge is final fluid enough to remove the room the blow down with the boiler more drum. The typical natural organic compound with the Crico branchiotinian has been usually traditional satisfactory result of the military boiler due to the diminishing of the favor of the new synthetic water soluble polymers tending to effect with the control minimization sludge contribute to the corrosion of the control since they absorb with a small amount of the dissolved oxygen helps to protect with the protective film on the metal steel surface. The effective of the tanning with the level should be maintained with over 100 parts per million effective component of the boiler with the water with the polymer material. The typically maintained between 5 to 20 parts per million active component. Most recent with the developed synthetic water soluble polymers have been shown with more than cost effective with the tanning with, for example, the polyacrylates and copolymers for the methyl acrylated sulfonated styrene or dispersant sludging scale inhibitors commonly used in minimizing formulation over the boiler. Polymer treatments are commonly found with the water treatment formulation available from the vendors. Corrosion in the boiler. Corrosion in the boiler results in improper pH level of the below 10.3 with the situation contribute to the general overall corrosion with the oxygen not being removed from the feed water with the situation that causes the pitting of the metal seal with the drums. General corrosion. General corrosion of the term refers to the overall the uniform corrosion of the metal surface, the adequate prevention of the general corrosion achieved with the pertaining to the proper pH and allowing the formation of the protective iron oxide coating known as the magnetite. Magnetite is a self-limiting form of the corrosion with the form of the outermost surface of the layer of the adherent of the metal seal of the tube with the surface of the magnetite composed of the iron oxide complex of the iron 3 oxygen 4 iron 1 oxygen 1 plus iron 2 oxygen 3. Alright, proper pH boiler with U up to 600 or 900 pounds per square inch of pH between 10.3 and 12.0. Adjustable boiler with the pH ring with achieve the recycling of the natural alkalinity combined with the feed water necessary adding chemical alkalinity agent, sodium hydroxide, caustic soda, the sodium carbonate, soda ash, and alkalinum phosphate treatment. Proper pH for the boilers of 900 pounds per square inch. Proper pH adjustment of the boilers 900 pounds per square inch is achieved by using the water treatment chemical, which are added because of the demineralized feed water is essential for the unbuffer the chemical treatment of the program that include with the carbonate coordinated with the phosphate, congruent phosphates, equilibrium phosphates, all of the while until the treatment of the phosphate of the program. The type are not used with the conventional with the precipitating agent for the hardness causing materials, but instead of the often used with the buffering agent of the pH from the C table of 2-1. So the conventional coordinated with the congruent and the equilibrium PO for OH and Na for the POH ratio of the pH. Pitting corrosion. Pitting corrosion is the term of the deep localized corrosion caused by the oxygen molecule of the metal surface of the boiler water. The process return of the form of the corrosion pit for the extent of the interior of the metal layer of the metal boiler component of the corrosion pitting of the can be served with enough level of the perforation of the tube surface. Other type of corrosion can occur with a high pressure boilers over the 900 pounds per square inch for the water treatment program. They include with the coordinate with the congruent with the equilibrium phosphate type of the chemical treatment that do not to be used with the same phosphate with the precipitating program and the other corrosion mechanism that include the caustic hydrogen and embrittlement and phosphate hideout. 2 seconds, removing oxygen from the feed water. And a very corrosive liquid resolve with the oxygen that dissolve with the water, the oxygenated water, particularly with the corrosive of the metals, mild steel with the almost always we use it to construct with the main components of the boiler system. The corrosive of the ray with the oxygenated water doubles with the 18 degrees Fahrenheit increase with the temperature for the oxygen corrosion be recognized by presence of the pits found typically in the top of the water line with a steam drum. The action can be removed with the feed water by mechanical chemical means or both with a combination of the methods of the usually common. Mechanical oxygen removal. The mechanical removal of oxygen for the feed water required with the deaerating heat of the mouth and both make up the water with the condensate with the term of the contact with the live steam of the mix for the heat of the tray with the sprays or both. The heating of the process literally strip the most of the oxygen and the other condensable gases out of the feed water, the oxygen, other gases, along with the small amount of the steam, the venting of the feed rate of the atmosphere. Deaerator operation. 2 key parameters associated with the deaerator operation control will maintain the maximum oxygen removal for the deaerator vent with a check with the verify the plume of the stem is always flowing out of the vent. Second, both of the pressure of the deaerator, the temperature of the outlet water control of the deaerator should be operated at pressure of 3 pounds per square inch or more. Given the pressure of the deaerated water outlet, the temperature again should be at 2 degrees Fahrenheit. Water temperature shown in table 2.2. Adjust for the altitude of the installation. The deaerator operating with low or no steam flow with low water temperature. The deaerator is not being operated efficiently, not removing the maximum amount of oxygen. And that deaerator pressures, deaerator water outlet temperature of the deaerator pressure per PSI gauge, deaerator water outlet in Fahrenheit. And then the note. Show the water in ventlet, spray heater, steam in, reboiler, spray, tube boiler, feed pump. Your vent, steam line, water, inlet, spray, tray, section, storage, and to boiler, feed pump. 262, chemical removal of the free oxygen. Oxygen scavenger chemical will react with the oxygen. Oxygen scavenger remove the oxygen from the boiler, feed water so that it will not cause bleeding corrosion. Oxygen scavenger for the boiler with up to 900 pounds per square inch. I conclude catalyte with sodium sulfite with unit uncatalyzed with sodium sulfite, both of which are oxygen scavenger source of the sulfite with the deaerator. You with the uncatalyzed with the oxygen scavenger with the sulfate and suffice. Can be fed with the storage area with the deaerator. You with the catalyte with sodium sulfite with the system without deaerator. Cobalt sulfate salt with which with the presence of the calcified sodium sulfite material with the U with the catalyzed sulfite react more quickly with the oxygen than with the uncatalyzed sulfite, both with the sodium sulfite with the catalyzed the must feed with the water with the upstream of the boiler, so with the action can be scavenged before the feed water ends with the boiler with addition of the schema. They also serve with the protective feed water piping corrosion. A sufficient amount of the oxygen scavenger must feed with the water meet demand with the oxygen initial with the presence of the provide the excess of the residual reserve of the amount oxygen with the oxygen level may increase with the unexpected water testing will always indicate the excess of the amount with the presence of the typical 2-3 type of the sulfite level of the boiler water. Boiler pressure from the PSI gauge and sulfite residual in the parts per million. Oxygen scavenger boiler of 900 pounds per square inch. The list of the oxygen scavenger includes specialty volatile treatment of hydroxylamine, hydroquinone, carbohydrazide, hydrazine, sulfite, erythrobic. Hydrazine can no longer be used because of the suspect with the carcinogen. Hydrazine, these special volatile treatments do not only scavenge the oxygen but also passivate with the metal surfaces. These chemicals are normally maintained with the boiler water parts per billion. Sulfide type of the oxygen scavengers can not be used with a boiler of 900 pounds per square inch because of the potential for the thermal decomposition, producing sulfur dioxide, hydrogen sulfide, both of which can cause erosion. Thermal decompositions are, and then show the written equations. These reactions are shown to occur at the boiler at pressures at 600 pounds per square inch. They do not usually create a serious problem until pressures exceed 900 pounds per square inch. Condensate corrosion and control. Cause of condensation corrosion. Oxygen and carbon dioxide are common steam condensate with the impurity that promote the condensation corrosion, less of the common process of the contaminants, each of the corrosive with the property with the independent of nature contaminant of the material that can be eroded. The piping found with a steam condensating system commonly constructed with mild steel, whereas heat exchanger usually copper and mild steel. Air. Air of the source of the oxygen with the condensate with the system, the condensate with the line with the usually intermittently with a particular suspect with the condensate with the corrosion, the cover with the cooling with the heat of the condensate with the line with the create with the vacuum with the withdrawal air with the system, pumping through the valve with the condensate with the tone with the addition with the dissolve the oxygen with the feed wall with the not commonly remove with the chemically with the mechanical with the can, and the boiler pass with the steam with the condensate line with the consume with the pitting of the corrosion acting with the metal surface of the oxygen corrosion with the condensate with the system, evidence of pitting of the presence of the corrosion with the product deposit with the called tubercles. Carbon dioxide or CO2 with the engine of the boiler system and the dissolve of the treatment with the carbon dioxide removed efficiently, effectively through the D area with the most common source of the carbon dioxide steam concept with the carbon dioxide 02 bicarbonate and ions alkalinity of the feed water under the efficient with the heat with the posture of the boiler carbonating the bicarbonate and ions alkalinity breakdown with the hydroxide with the ions alkalinity carbon dioxide gas with the carbon dioxide is volatile leaves and boiler steam. Steam is subsequently condensed to the carbon dioxide dissolved with the condensate with the form of the carbonic acid. Lower pH condensation with the corrosive mouse amount with a particular mild steel. Figure 2.4 with the eucricon of the carbon dioxide corrosion thinning of the condensated lime walls, particularly with the condensated liquid level within the pipe of the pipe thread with the condensating flow with preventing corrosion in the steam, the boiler steam, neutralizing carbon dioxide volatile aims, and it showed the corrosion rate and estimating carbon dioxide and steam of the corrosion engine with the useful of the known amount of the carbon dioxide in the steam. The seventh, the return of the investment cost to save with the remove of the carbon dioxide, proof of the cost of even the internal chemical with the treatment, the remove of the carbon dioxide, engineered water treatment, the surface of the company, with the estimate of the amount of the carbon dioxide, properly estimated amount of the neutralizing amine, water, treatment of chemical that must be with example 5 that illustrates this illustration. CO2 level of the steam that can be estimated with the amount of the bicarbonate with the carbonate with the alkalinity with the feed water file with the PM and M and alkalinity measured with the compound. And then it shows carbon dioxide is equal to bicarbonate 0.79 plus the carbonate 0 times 0.35, or carbon dioxide is equal to total methyl orange alkalinity minus 2 phenethyl alkalinity times 0.792 times polyethanol alkalinity parts per million times 0.35. Control of the carbon dioxide with neutralizing ammonines. Ammonines are organic compound with contained with nitrogen. Groups similar with ammonia that refer to the neutralizing ammonine with the boiler application together with the neutralizing acid with the carbon dioxide with the condition raising with the pH with the condensate with the ammonine with compound volatile escape with the boiler with the steam to evaluate the dissolve with the steam condensate. Control limit. The ammonine with the ebb with the maintain with the pH of 7.5 to 9.0. Ideally 7.5 to 8.5. All parts of the condensate of the return system. The condensate with the pH level that should not be allowed to fall below the 7.5 anywhere with the entire condensate with return system. The corrosion will occur with the shortest strip. The Navy require with the 8.0 to the 9.5 pH. See table 17 with the ammonites fed separately with the other chemicals that are fed with directly with the boiler system. Shown with the vaporized with the travel with the steam. And the steam lines with the continuous ammonite feed with the maintain with the constant effect of the pH when the standing condensate with the table 2.4 vapor liquid recovery, vapor to liquid distribution ratios. Moropropylene, diethanol, diethynyl ethanol, and cyclohexylamine are 3 neutralizing ammonines approved the using of the military boiler for the steam condensate with the condensate of the return system. The strip of the multiple heat exchange with a different location along with the steam the distribution system. Some of the ammonines tend to fall out into the condensate with the legs with the closer for the boilers, while some of the ammonines tend to stay when they come out with the condensate with the toe over the end of the steam distribution system. The degree with which for the curve of the called the vapor liquid distribution ratio with the expressed vapor liquid distribution ratio of the ammonine steam phase with the ammonine condensated phase, or divided by the ammonine condensate phase. And then you have your property monothreonal DEAE, cyclohexamine, and physical chemical property neutralizing ammonites. Amanites have a different vapor-liquid distribution ratio than that. We work equally in all systems depending on the particular amonite with the effect of the short and even the long distance condensating line, complex condensated return system that optimize the result of the obtained with the choosing of the appropriate amonite combination of the system by system base for the neutralizing amonite selection chart with the table 2.5, often the blends for the different amonites used. And this show for the amonite table chart. Morpholine. Morpholine is a low liquid distribution ratio. Will drop the stream quickly, making it suitable for the protecting concept of the return system. Short, moderately with the morpholine. Morpholine is best suited with the high pressure systems of 15 to 900 pounds per square inch because of the high boiling point. Very little morpholine D area is returned to the condensate. The DEAE very liquid ratio is the morpholine with the cyclohexylamine makes DEAE good chain with the protecting systems of moderate length with the morpholine cyclohexamine. You separately with the provide with the complete protection of the low boiling point. Make sure DEAE makes the DEAE suitable for both low pressure boiler and high pressure. Alright, cyclohexylamine, high vapor liquid distribution ratio, the consequently best suited for the protecting the extremely long system. The cyclohexylamine can also be used with the low pressure system. Cyclohexylamine is not used in the system feed water alkalinity exceeds 75 parts per million because of the low stability with cyclohexylamine bicarbonate produced with the form of the deposit of the like areas. Formation of the deposit of the low flow area of the far end of the condensate of the return side. The system positive reprogramming to avoid producing feed water alkalinity by using DEAE. Also necessary treatment along systems of the morpholine and early parts of the system where the steam is first condensed. Alright, amines blend. A mixture of the morpholine with the DEAE with the cyclohexamine with the provide full protection of the medium large system with the optimum blend with the amine to determine the maximum measuring with the actual pH of the condensate of the various location condensate with the returns for the sample of the far section with lower pH. The other example, the cyclohexamine mixture could be increased with a device for the ratio of the pH survey should be done with the blending ratio change. Initial blend of 1 part cyclohexamine to 3 parts morpholine is a good starting point. Our controlled carbon dioxide, oxygen, and filling amines of the carbon dioxide corrosion can be controlled with 0.7 to 1.0 parts per million with the filming ammonine, such as the oxidectium and sodium. The chemical with a coat condensate with the prevent of the carbon dioxide water with the coming in with contact with the pipe wall filling ammonine, but there should be appropriate to use a higher degree of the alcohol leakage. Oxygen because of the coat with the metal with the air, but there should not even the condensated system have the corrosion problem was passed. Excess absorption of the filling ammonine with on the brush with the curve of the amine with the dislodge with the rust and cover to be returned the DNA of the opera or the boiler rate of mining filamine amines continually during the operation. Are directly in steam header with the quill with the instep of the steam of the drum with the essential of the additional inadequate doses can resolve the accelerated pitting type of the corrosion with incomplete surface coverage may need written authorization form appropriate to show that the use of the filament and the with the military boiler. Our control of the carbon dioxide and oxygen special volatile ammonine. Some of the special oxygen scaffolding described in the boilers of 900 pounds per square inch can be used for the purpose of the control of the both carbon dioxide oxygen. Special volatile ammonine include hydroxylamine, hydroquinone, carbon dioxide, hydrogen sulfide, ethiopic acid. The work with the both raising pH of pH condensate with a scavenging oxygen passivity metal surfaces may not be appropriately restricted the Food Drug Administration to know that the chemical may not need the good operational military boiler plants. Ammonine limitation indoor aim steam quality issues. 21 CFR Part 173 310 restrict the using common neutralizing ammonine filling with ammonine with the limitations summarized with the table 2.6. No, the limitation table 6 of the maximum level of concentration using ammonine is not always advisable. Ammonine addition not continue with the boiler operation cycle with the shutting down of the boiler with a couple of hours each day. Maximum ammonine construction concentration may vary widely exceed limit even though the average concentration is within limits. And this show the ammonine limitations. Are steam used for sterilization. Some of the facilities of the hospital, particularly with the steam and the autoclaves, of the purpose of the sterilization equipment for the serological event, instrument of the office, concern with the neutralizing the ammonine of the man, leave the ammonine content. The equipment in some of the de-alkalizer process of the makeup of the boil over there by reducing the lowest level of the bicarbonate. Carbonate alkalinity is an alternative to the using neutralizing ammonines. Using the dealkalizer effectively reduce the most immediate use and eliminate the need of the neutralizing amine to reduce the carbon dioxide corrosion steam due to steam heat exchangers may use the raise the sterile steam. Food preparation. Use the neutralizing amine to prohibit the steam contact with the milk or milk products. In addition, to provide with a margin of safety, military prohibits the amines steam used directly cooking for these may be sufficient reason to prevent using building steam with the food preparation kitchens. Some cases, the kitchens use the steam heated jacket and kettle to which feed food is heated. The application of the steam and heat source does not include direct contact with the steam with the food stuffs. In other cases, the direct contact between the steam and the food stuff is method used to provide heating of the maybe the consume of the ammonite to impair the ammonite taste the odor of the food with the elevated with the consume of the use of the packaged steam generators to produce sources of steam with the independent of the building system steam. Another alternative is to use the steam heat ratio. Humidification, as the steam often used to humidify the air of the building, use the air the means of raise the concern of the contamination of the air of the building. Provide the marginal safety of the military probe using amines and steam to be used directly for humidification. Normally, quantity of the amine with the air stem humidified building is quite small, usually low parts per billion. However, the packaged steam of the generators can eliminate the concern. Alright, your water carryover in system. The steam that is produced with the boiler water should not contaminate the liquid water. Commonly caused with the water droplets with impurity being carried over the system, misting, foaming, priming, and silica carryover. Mist carryover. The term misting refers to the process of the 5 minutes of the produce of the water boiler over the stage processes of the illustrated figure 2.5 of the stage 1 of the boil of steam. Vapor reaches the water surface of the stage 2 of the bubble bursts, leaving the dent in the water with stage 3. The water rises to the fill of the dent, center of the dent filled with the faster rate of the edges, result with a small droplet of the boiler water is thrown off the fine mist. Most and not all of the mist is removed with the most mist eliminator section of the steam drum. However, any of the mist does not remove within train within steam, with the final droplets will have the same level to dissolve of the boiler water will contaminate steam condensate. And then so stage 1, stage 2, stage 3, boil formation, surface indentation, after bubble droplet formation, water boilers mist formation. Foaming carryover. The foaming carryover refers to the boiler water foam carryover the foam into steam of the very condition of the column of the foam, except for the level of the alkalinity, the TDS, SSS, and at times the water treatment of chemical will interact with the create of the foam and the boiler with the neutralizing the total alkalinity of less than 20% of the TDS. The total suspended solids is less than 8% of the TDS of the control forming result. Reasonable level of addition and adding anti-foam agents to the boiler water can control foaming. Polyamide glycos are example of the anti-foaming agents. Prime carryover. The priming refers to the boiler water and the steam. The tube of the liquid variation serve the steam drum of the water mixed with the steam subsequently carried with the steam head with a mechanical properties such as the oversensitive the heat, feed water, large steam demand. The incorrect blowdown procedures always cause priming. There are no chemical control method available, although additional anti-foaming chemicals may help reduce the extent of the occurrence of the boiler. Operators should be reviewed and modified by priming carryover has occurred. Silicate carryover. The term silica carryover refers to the situation that occurred with the silica of the boiler water valve states, and if the steam and independent of the water carryover, silica then off the form of the deposit of the condensate line with the process of the equipment, and with the silica the condensate with the steam. When the steam turbines are used with the silica deposition of the very surface, the resulting unbalancing of the steam turbine blade with the maintaining low silica level of the boiler water control. Control silica carryover the acceptable level depending on the boiler operating pressure. Table 2.7 shows the suggested limit to boiler over pressure PSI gauge silica parts per million. Alright, determining water carryover in the system. Steam of the water wave to determine the any of the water carryover occurring in the measure of the conductivity of steam with the steam concept of the dry set. Detect 25 micro MHOs. Conduct with the concept of the carryover over the probability and significant conduct with greater than 25 micro MHOs. You should investigate and identify the cause. Conductivity measurement, implementation, conduct the measurement of the 25 micro MHOs. Steam of the concept that indicate that there is either carryover leakage of the steam of the condensate of the system. According to the test, hardening the condensate must be performed if the hardening of the condensate and the contamination condenses likely due to the raw water leakage for the condensate of the system refers to the boiler water. Carryover the boiler water is very low. Hardness of the raw water may be the cause. Deposit analysis. Any deposit feed system, steam condensating system, should be analyzed. Determine the source of the deposit of the most magnetic iron oxide due to the corrosion mild steel condensating system. Utilizing eminence control of these deposits. If the deposits are most likely silica, increase the blowdown with the removal of the silica with the makeup of the water can reduce the if the deposits are most likely sodium salt, sodium hydroxide, sodium carbide, sodium chloride, sodium sulfate, sodium phosphate. The cause is probably the boiler water carryover, the misting and priming and the foaming. In Chapter 3, testing.